Hello, Algebra 2. Hope you guys are having a great day. Um, Today, in this video, we're going to talk about inverses of functions, which we've already done a bunch in class, but now we are going to have a few more tools in order to figure out what an inverse of a function is, or figure out if two functions are inverses of each other. And then we're going to talk about something called the horizontal line test, which is related to the vertical line test. Okay, so before we actually get into the new stuff, I wanted to recall a little bit of old information that we've done before about functions and their inverses. Okay, so number one, we're just going to review what the vertical line test is. So basically, if I have a graph of any relation between x and y, if I can draw a vertical line anywhere on the graph, then without touching the graph more than once with a single line, then the graph, the relationship between x and y, is a function. Number 2 through 5 are all about inverses of functions and how they are related to each other. And so the second one is, if you have a graph of a function, then the graph of its inverse is going to be a reflection over the line y equals x. The next one is that, remember, the domain of a function is the range of its inverse, and the range of a function is the domain of its inverse. So your domain and range are swapped. Number 4 is just to remember that inverses undo each other. So if you add something, say you have a number 10 and you add 3 to it, and then you do its inverse, right? The inverse of addition is subtraction. So if I add 3, to undo that adding 3, I have to subtract 3, right? Same thing with multiplying, same thing with any sort of inverse relationship, right? So a function and its inverse, those undo each other. And last but not least is how to find the inverse of a function, right? Remember that you have to switch x and y. You have to do that. And then you just solve algebraically for y in terms of x, and then that is your inverse. Okay, cool. Also, just remember that with an inverse and a function, right, the x's and y's are swapped, which is the same thing as the domain and range being swapped. It's also the same thing as the reflection over the y. Y equals x. Line y equals x, right? But just, as a refresher. Okay, so the first new thing that we're going to learn is the horizontal line test. It's very similar to the vertical line test, except now it's with horizontal lines, okay? And the basic of the horizontal line test is, if you have a graph and you can draw a horizontal line anywhere on the function, or on the graph, right? And you only pass through the graph once, or no more than once, then that function's inverse is also a function, right? Because basically what happens when you take a function and then find its inverse is it takes the graph and it makes it go like this, right? So it would eventually pass the vertical line test once you actually found the inverse. So let's write that. So if you take a look at my examples below, each one of these, the first 3 at least, are functions, right? Because they pass the vertical line test. Bam, 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 bam. Right? That one's a function. This one's a function. This one's a function. Right? The last one is not a function because I touch the graph twice with the vertical line passing through it. But the horizontal line test checks for the inverse of those functions. So on the first one, if I draw a horizontal line, I see that I touch the graph twice. That means that the inverse is not going to be a function. It still exists, but it looks like this, right? And that's not a function. Next one, same thing. I can draw a vertical line and touch the graph 1, 2, more than once, right? The inverse is not a function. Same thing here. Inverse is not a function. With the last one, even though the original function itself or the original graph itself, isn't a function, its inverse is, right? Because I can draw a horizontal line anywhere and not pass through the graph more than once. So this one, the inverse of it, is in fact a function. Okay, so there's your little summary. Okay, next, how to tell if two functions are inverses of each other. Okay, so this goes back to stuff that we learned in the last video, which is composition of functions. So you're going to need to make sure you are solid on that. But basically, right, a function and its inverse have to undo each other. So if I take the value x, right, and I apply f to it, right, then to undo the f, I should be able to take the inverse of the function. Okay, so I should be able to do f inverse of f of x. And if that ends up equaling just plain old x, and then I have to do it the other direction too, take f of f inverse, then those two functions are in fact inverses of each other. So basically, if you have two functions f and g, and you're trying to see if they're inverses of each other, you have to take f of g of x, and then you also have to do g of f of x. And you have to make sure both of those equal x once you simplify them down. If that's the case, then they are in fact inverses of each other. Okay, let's start with number 1. Are f of x equals 3x plus 1 and g of x equals 1/3 x minus 1/3, are they inverses of each other? So I have to plug g into f, and then I have to plug f into g. So let's do the first one. Let's do f of g of x first. And f of g of x is just taking g and plugging it into f. So now I have f of 1/3 x minus 1/3, because that's what g of x is. Then I need to take this, and anywhere I saw an x in f, so right there, I plug in this value, okay, that expression. So I've plugged in g into f of x, and then now I just simplify. So 3 times 1/3 x is just x, 3 times minus 1/3 is minus 1, and then plus 1. Okay, that does in fact equal x, but just because that one equals x doesn't mean that the next one will, so you have to make sure both of them equal x. Now I have to plug f of x into g. Okay, so here we go. Replacing f of x with whatever f of x equals, which is 3x plus 1. Okay, and since g of x is 1/3 x minus 1/3, I'm just taking wherever I see an x, so that's right here, I'm replacing it with 3x plus 1. I'm just plugging that in for x. And then I just simplify. Distribute my 1/3. 1/3 times 3x is just x. And then 1/3 times 1 is 1/3 minus 1/3. Since x plus 1/3 minus 1/3 equals x, and we have f of g of x and g of f of x both are equal to x, then we know they're inverses of each other. Yay! Okay, example 2. Are these two functions inverse functions of each other? At this point, pause, try it yourself, and then you can press start again and check your answer. Pause. So for this one, I only had to do one direction because I did h of I of x, and I found out that that equals negative x. And that's not x, therefore they are not inverse functions of each other. Alright, so that's the answer to number 2. And then number 3 is just finding inverses. It says find the inverse of j of x, and then determine if the inverse is also a function. Okay, so either you have to graph j of x first and do the horizontal line test, or you find the inverse, then graph that and do the vertical line test on the inverse. Or you can kind of like rationalize your way through the answer. I'm going to find the inverse first. Step number 1, rewrite with a y. Okay, great. Next step, switch your x and your y. Now solve for y. Add 8 to the other side, divide by 2. Now to get rid of the square, we want to square root both sides. But what happens when you take the square root of both sides? You have to have a plus or minus, okay? Don't forget that. So then that cancels my square root and my square. Those cancel each other out. And then I'm just left with y minus 1 equals plus or minus the square root of x plus 8 over 2. And then I can just add 1 to the other side. So this would be the inverse, okay, of our original function. Okay, the only problem with this is if you notice, when I plug in something for x, most of the time I'm going to get 2 values for y. And what's wrong with that? Well, it's not a function. It's okay, the relation is still an inverse of the original function, but the inverse itself is not a function, so you cannot write this as f to the negative 1, right? That inverse notation, because it's not a function. So you can't do that. So you just have to leave it as y. And other than that, just some things to note. The original function is a polynomial, or it's a quadratic, right? And it's vertically stretched. It's shifted right by 1, down by 8. So it kind of looks like here's 8's my vertex, 8, and to the right 1. And then my function looks something like that, right? So if you take a look at that, my inverse, my domain's negative infinity to infinity. My range is from negative 8 all the way to positive infinity. Which means the domain and range of the inverse, which is this guy, are going to be the opposite of that. So the domain is going to be negative 8 to infinity, and the range is going to be negative infinity to infinity. And if we wanted to sketch this, we could draw a line, the line y equals x, and then reflect the function over that line and get our inverse. And as you can see from the graph, this clearly does not pass the vertical line test because I can draw a line and hit the graph twice. So the inverse is not a function. The original one was, but it's okay. They undo each other. And it's interesting to look at.